Okay, welcome back everyone. I've already half introduced Frank. So Frank Van Prague is here from TIBCO Australia, so thank you very much for coming, Frank, specifically. Me and travels more than Santa Claus does. It's very great that he's come along today and to really show us what analytics is about and how Spotfire does it so well. Over to you, Frank.
Thank you, Marcus. So yes, Frank Van Prague. I work with TIBCO, the company that built and sells Spotfire, that is now available under the covers within the Smartabase product. Yes, I travel a lot. I enjoy it. I live at the Qantas Club if anybody wants to come and visit me. I thought today what I'd do is I'd talk to you about predictive analytics. It's something that is of interest to pretty much everyone, to be able to predict what's happening in a team, what's happening with players, what's happening with any data. But I do have to give you one caveat, and that is I'm not a sports scientist. I'm what I call data enthusiast. So I play with data from all fields, and I tend to pick up knowledge. And I've worked out that TSBs and sleep and all of those pieces of data are all great indicators and pieces of data that we collect in the industry here. But of course, a week from now I'll be working with a mining company or with a government department. So please don't push me on the actual domain expertise that you obviously bring to the table. But let me tell you, data visualization is very, very powerful, and I'm here to show you why. I'm also going to sit down because there's going to be a little bit of interaction here with the keyboard. To begin with, data visualization is let me just go back to the beginning here. Giving it all away. Jumped ahead. Data visualization is something that happens in our brains, and so those brains of ours are particularly good at taking visual information and understanding what it is without actually cognitively having to work through things. It's just instant. It's the back part of the brain that does its visual analysis, and if something is in red, it kind of stands out to us. You don't have to train people to do that, and that's the beauty of data visualization. Coaches, athletes, any person in the world that you pull off the street, when you show them a graph or when you show them something visual, they start to detect patterns in it quickly and can take some action out of that. And that's essentially what visualizations are about. It's about people taking action based on what they see. Why are our brains so good at it? It's because over many, many millions of years, we have evolved to avoid predators and to forage for food. Our brains are now particularly good at sensing these things because it means survival for our brains. Sometimes though, when you're looking at data, when you're looking at information that's presented to you, it isn't immediately obvious what it is that you're looking for because things can be camouflaged. That's where data visualization comes in, to make sense and to bring out to the forefront the pieces of information that you need to know, the answers to the questions that you probably didn't even know you needed to ask. Visualization is great for that. And you've got so much data in Smartabase that's a great area to start pointing technologies at, like Spotfire, our data visualization technology. You point it at that data and you can begin to swim through it and find correlations, find interesting data, find which athletes are having trouble. And I'm going to show you a little bit about how we would go about building those visualizations. You saw some screenshots earlier that Murph put up on the screen, and you're probably thinking, oh well, that probably took a week to build or a day to build, and it's complex, it's hard, we can't really do that. Well, not so. What I'm going to show you now is how I can go into a desktop application called Spotfire Author. It's the application that the Smartabase people use, the Fusion Sport people use, in order to take data out of Smartabase or out of files or spreadsheets or Excel databases or anything you like, and you just literally import it. And I'm going to show you, I've got some athlete data, 100 rows of athlete data here in a file. I'll just drag that onto this surface here, and as you would expect with products like Excel, it just shows you initially what kind of data you happen to have here. And it says, well, you've got a string row here that's called athlete. I'll call it athlete. It's got these values in it. Then we have stress, total distance, sleep hours, high intensity running, TSBs, and to be viewed by. These are columns that we've got with data in it. And I can scroll down and have a look. And I say, yes, okay, that's indeed the data that I want to import. First thing Spotfire does, I'll make it a little bigger, is it creates a visualization. So you can see that data. Some of those columns pushed against the x-axis, like the sleep on the x-axis. Somebody had 7 hours worth of sleep around about there. Going up on the y-axis, you've got the high intensity running in meters. So you can see immediately a correlation here. The people that sleep short hours are running shorter distances as far as high intensity running is concerned. It's like a pattern that just jumps out. That's how quick and easy it is to get started with any data that you've got. Now, of course, in Fusion Sport, Smartabase rather, you'll typically just point it at any data that Smartabase has available, and that's the data you're going to be reporting on. But you could just as easily take any other data source and merge it in or mix it in and do what you want with it. Let me show you a few other little tricks. On the right-hand side, I have what's called the filter panel. I may only be interested in a certain number of athletes, so I can highlight them, and interactively it shows me those athletes. I can see that there was a stress measure that was collected there as well. One of the columns was stress. It goes from 0 to 11. That gives me a little bit of information. I may not be interested in the stress type people, so I can pare it down like this and just filter out those ones that have high stress levels. You notice that I colored this. This was automatically colored by stress levels, and if I take out everyone that had stress levels greater than 0, all the colors are uniform in red. So I might like to actually make them green. That's how easy it is to start working with this with your data. Now, secondly, I can see here that that there are a number of coaches that are listed here. If I just highlight a few coaches, now I'm just looking at those coaches. I can take the coaches like this and just drag them across, and you get this panel that turns up where I can put it on the x-axis or the y-axis, the coaches. But I want to change the color so that I can see colored in groups which coach has got which players, and that gives me an idea, you know, who's sleeping well, who's not sleeping well, and what is how is it in relation to their high intensity running. Now, I might be more interested in TSBs versus sleep. So I could drag the TSB column, just drag that across, and I can put that on the y-axis by dropping it here, or I can physically take it to the y-axis and just drop it there. Easy? That's how easy it is for the Smartabase people, for Fusion Sport people, to pull these things together for you. It's straightforward. And it means that if you have specific visualizations that you want to be able to see this against that, and then filter things out, they can build that for you, create a report, put it into Smartabase, and have it available to you. If I was doing it, it would be 10 minutes, but it might take them a day or something like that to kind of get it out there, to schedule it. But it's very, very straightforward. Now those are basic visualizations. I've only shown you a scatter plot, but at the top here, they can do bar charts, line charts, pie charts, 3D plots. I won't put them up there. They'll be a bit much to look at. But here I've just created a whole bunch of them, all against the same data. And it's all a bit scrunched up, so I might want to just get rid of some of the color coding and the key on the right hand side. But it's interactive, so as I highlight these, you can see where that relates to in other visualizations that you've got. And then the next thing is, of course, to be able to drill down. Drill down, very, very powerful feature. Suppose that I want to mark this pie here, because the green, they had level 2 stress. I would say, take that marked row and filter to it. So I just filter to that one, and now all the data I see just relates to stress levels of 2. Yeah? I think I've said enough about the basics. What I want to show you now is what can that give you? Well, I've been working with a number of sports, the AIS has been a great customer for us to work with, and I've had exposure to very many sports, including swimming and rowing and canoeing. This is some data that I got out of some public information around a particular swimmer in a particular meet, and I just loaded the entire Access database in and then focused on this particular individual and 2 races that he swam, and we can now very quickly and easily compare their velocity versus the split, so the first 25 meters, etc., across the x-axis, and then the velocity on the y-axis. And you can see that they were kind of dropping a bit low there in that first race, but in the second race they really picked it up. There's a lot more information that we can then put here. We can do the stroke rate versus the split name, and then put all that information in a table and highlight the outliers. So highlight in red things are maybe a little bit high or a little bit low or out of their usual bounds. And at the AIS, the interest has been very specific around comparing individuals with their own data, not data across a sport, but just are they outside of their own band, their own norms. So these visualizations will happily do that. That took me about an hour to produce out of an MDB file, a database file that I was given. And that's one of the reasons why they get very excited about getting this data poolside in the case of swimming, because they can very quickly be able to compare data that they've collected in an exercise. Other data that I've got here is when you want to perhaps look at, this is the more interesting side of things. Here you've got a de-identified list of athletes, but this one's got a cross against it because there are some indicators. Here's an indicator that happens to be stress maybe, and this happens to be sleep hours. Indicators have gone off to indicate that there could be a problem, and it also notes that that individual has been injured. And you can then see the general health for that person has been trending down, going red, over the last few days, and that's probably why that indicator has hit there. And you can also see their injuries. They've got a current hand injury and a current other injury. If I was in a live environment, I would hover over this to actually see what the injury was. And there is a treatment, so they've had some treatments on this area here where there is no injury. We might just be looking at a few days. You can glean lots of information from these visualizations. Now, how can you actually put that to good use within an industry like yours? What we tend to do is we look for insight in order for someone to take action, and the action is typically taken by the coaches who get the athletes to take that action. But that insight, it requires a lot of data, which the coaches probably don't want to really wade through. Like Marcus said, they don't want to see some kind of massive model or piece of code that's just not interesting to them. They actually want to get information to them that helps them in avoid things or take advantage of opportunities. So the model the approach that we take is to understand the data first. Data's coming into the environment, is being collected, coming into an environment. You can look at that data and understand it. It's backwards looking, it's historical. It's looking in the rear vision mirror. You're trying to move forward, you're looking in the rear vision mirror to see where you've been and the trends that are developing. Then we take an approach, and this gets into the level 3 or phase 3, phase 4 that Marcus was mentioning around the analytics. Then you start to want to create models. Those models, many of you are probably already creating them in tools such as SAS or MATLAB or others, or R, a great modeling environment. You can leverage all of those models that you've got through a visualization, because it's the visualization that goes in front of an individual to make an insightful decision and take action. But it's the model underneath that has the smarts in it. So we don't really mind what technology you use the models in. We don't mind. R, the open source engine that is great for modeling, just happens to come under the covers with Spotfire and hence comes with Smartabase. But you can use any system you like and feed it in and get those visualizations out there. So you get the models. You can look still backwards looking at your original data. You might actually cut the data set in half and say, here I've got a bunch of injuries that have happened historically. I would love to be able to predict those injuries looking forward in the future. So you cut the data set in half and you build a model you run on half your data, so that when you think your model is good, you can point it at the other half of your data and verify that the model is working. So the other half, which your model has never seen, and we know because it's historical data, where the injuries occurred, when they occurred, what the injuries were, how long they were out for. The model can then put in a prediction and say, we think this guy's going to be out for 6 weeks, this guy's going to be out for 1 week based on the injury, or this guy is going to develop an injury that's going to take them out for 6 weeks. The model can predict that, and then you can look at that historical data set and compare and say, yes, the model was right, or oh, the model was a bit off. And then you can refine that model. Now the action part, actually, the next part is to take that model and put it out there so people can make use of it in the field, so that they can insert a predicted column that says, are these individuals likely to develop an injury, or likely to break, or have poor performance, or miss an event based on the historical indicators. You can look at that, and if it comes back with a affirmative yes, 80% chance they're going to miss a game, then you can act and do something about it. Get the right information in front of the right person at the right time, so they can still take action to avoid a disaster or to take advantage of an opportunity. Alright, so the first step is to know your data, and we typically look for indicators. Marcus mentioned cause and effect. Yes, always very important to understand what's in your data and how come these correlations happen. But number one is collecting the data, collecting the right things, like heart rates, TSBs, whether an injury is really an injury, how you classify all those things. All those things are indicators. So I'm going to show you now within Spotfire, a visualization environment, how I can work with a bunch of indicators and start looking at them and try and make sense of them. So I open, close that, I'll open this one I prepared a little earlier, and it's very similar data that I just imported earlier. And the indicators are stress, how much stress the athlete is reporting. That athlete this is just current, historical reporting on stress, distance that they ran, their TSBs. Now I have to say these numbers are made up because I can't really take numbers out of real athletes and put them up on the screen here, so I've just made up numbers that show a bit of a trend. And we can see that this record here with these indicators developed an injury. Okay, and these other ones as well. I've also mapped it out on a body chart that the AIS commissioned. They wanted to see where injuries are occurring, so we can highlight it, and it's interactive. So if I say upper body injuries, you can see on the left upper body or the lower body injuries. But these indicators may be able to predict an injury. So let's have a look what the indicators tell us. This is for a much larger data set than I loaded in earlier. And what I can see here is, I'm just going to take the sleep out. I want to put everything on the left-hand side, so I'm just going to take every column, every row, and just spread them out across here, and then color them by whether or not they did an injury. Now I can see a relationship, a correlation. When you look at the TSBs of individuals, the chances of them developing an injury is far greater when the TSBs go, in this case, over about 150. But if you went and said, okay, we'll put a note out to coaches that if their TSBs goes over 150, then they're going to develop an injury, it's not a good model. It's too single, focused on TSB. And you're going to get all of these blue points, which are people that are not injured. So the coaches are going to be pulling people off because the system is telling them to ease the load, even though they're doing great. Look at this guy. Would you want to pull them off? They're not developing an injury. They're probably a very elite athlete. What about the other indicators? So I'm going to take sleep here. I'm going to just drag that onto the y-axis as well. And what's going to happen when I put it on the y-axis? It's going to say, okay, well, how do I visualize two things on the y-axis? And it says I'm going to have to separate out those row numbers with the column names. I'm not going to explain why it does that, but what I will do is I'm going to separate those column names so that I trellis the display into two separate areas. Now I can see the sleep at the top and the TSBs towards the bottom, but the scales, the sleep, you measure that in hours, and it's like between 0 and 10, so it doesn't look particularly good on this scale. So I'll just right click on the scale and I say give us multiple scales. Now I can see information and indicators in the data that tell us, so maybe I should get a combination of TSBs, because I notice that they get injured when their sleep goes up. I don't know if that's a true observation, but that's what I've peppered into the data. And their TSBs, that's the TSBs there, also injuries are more likely when they go up. So maybe it's a combination of the two. Those are my indicators. And of course I can continue to add things like total distance covered, put that down there. I'll just get rid of these other visualizations that are not really helping us at this point. And again, there's a few points in here where they haven't developed an injury. I'm going to make them green. So green, no injury, red is an injury. Those are the indicators. And we've actually just also found some data relationships. There's a relationship between sleep, TSBs, etc., and the whether or not they're going to do an injury. So I've just done that demo. I don't need to go through that again. But the next step is to find a predictive model. Now I'm going to fast forward, okay, to the coach or to a Smartabase person having a discussion with a sports person, saying, I have a model, I've developed a model that can help you predict, in this case, injuries, because I've put that through Spotfire and I've created that model. It sits in a little file, and you might like to apply that to your unseen data. This is, data, well, it's future. It's we've just picked up all these indicators as they are right now. Our model has never seen this data before, but we want to be able to predict whether or not these guys are going to develop an injury based on these indicators. And this is how easy it is for you guys or for a Fusion Sport person to take a model and insert a predicted column. So we're going to insert a predicted column into this unseen data, that a model will take that unseen data and all of these variables and say, based on that, these guys may have an injury soon and these guys may not. So I insert a predicted column. I find that little file that Fusion Sport put together called My Model, might be called My Injuries. Under the covers there is a bunch of our code that's generated automatically, and I'm going to show you through the remainder of this talk how I create that little file. Okay, but I'm just looking at it now from a very high-level customer perspective, your perspective. So we pick up that file and it says, okay, this is a model produced by that person, and it needs to know what the stress indicators are, the distance covered indicators, the TSBs, etc. Do you have columns in your data that contain stress, body load, sleep, TSBs? Well, I do, and I've actually named them the same because it's so convenient then to map them. And it picks it up and it says, okay, I can put that in. And it comes up with this class prediction. These guys are not going to be injured, and there are a few in there that may be injured, like these guys here. They may either have an injury now or are developing an injury. And of course, you would then go through and change this visualization maybe into a pie chart, color it by that injury prediction, color it by, in a moment, looking at the athlete data, color it by whether they're going to be injured, marking that one so that you can see just the guys that are going to be injured, and then you can take action. You go into the file, insert a predicted column, and I can begin to work with it. Now the question in some of your minds is, how might I create such a model? And that's the next phase that I'm going to show you. By the way, I'm using Ctrl-Z to undo all of the work I've just done, because that's just part and parcel of how this technology works. You can undo lots of things. This is how at the moment, Fusion Sport would create the model, but ultimately you guys can create this model too, because it isn't that hard. Let me show you how it's done. I would use a classification model. So I pull down tools, I say, I want to create a classification model to take these indicators and classify people as injured or not injured. I would then say, I have a table in memory with this training data. In the training data table, I've got because it's historical, backward looking in the rear vision mirror. I've got a column that says whether or not they were injured. I want to predict from that injury column whether or not they were injured or whether they were not injured. The indicators that I have that I can play with are all of these ones. They're the observation ID, observation 1, observation 2, observation 3. Obviously it's not going to have much of a correlation to predicting an injury. But I also have stress levels and TSBs. They're more likely to give us an indicator of whether or not an injury resulted. But just for the exercise, I'm going to take the observation ID as well to see if there happens to be a correlation there. Then, in this environment, it shows me how that model is working for us. I'll just move things around a little bit to make it a little prettier. But I can see, again, through visualizations, that the TSB comes up top in the importance. That is an excellent indicator for whether an injury has occurred historically. And stress is only very moderate indicator of whether an injury has happened. But the observation ID, observation 1, 2, and 3, and 4, those numbers have pretty much nothing to do with predicting injuries. So I can go back to the calculator and say, okay, well, let's take out that observation ID. That's not doing anything for us. Take it out. Hit OK. And it shows me the same thing. And this time it says, it's missing. And it's all of the variables that we fed in are relevant by the looks of this. I can also see on the left-hand side for the statisticians in the room some statistical information that tells me how good this model is. I love this ROC curve. The ROC curve says the model is fantastic. It is very specific, this model. It will either say, yes, they've got an injury, or it will be a very clear, no, they're not developing an injury. If this was a straight line, it would be more like, there's a 62% chance or a 48% chance, not a great model. This model is good. So I want to test my model now. Remember, I cut my data set in half. I've got half the data that I've built the model on. Now I'm going to take this historical data and run the model against an historical data because I know the outcomes. I know whether an injury developed in that historical data. So I'll evaluate my model. The table that I've got is called the validation data. Has the same column names. So I just map the same column names. Yes, the injury column, the TSB column, etc. And it creates another visualization that evaluates the model I've just created, shows me that it very clearly makes decisions about the predictions, either yes, a full yes, or a full no. Here's what's called a confusion matrix, not to be confused or not to confuse anyone. But it tells us if we predicted that someone would not be injured, then 1,017 times they were actually not injured. But we did have a few false predictions where we predicted they wouldn't be injured and they actually were injured. So there is some error in the model, but it has 93% accuracy. Is that useful? I think it is useful. This, in fact, is a fantastic model. I'd be happy with even 80% accuracy. A few false positives shouldn't mean that you discard the entire model. You can actually make a great deal of value out of just the true positives. And the last step that the Fusion Sport people would do is they would just take that little file, export it, and call it injury prediction for cycling. Because they may have taken this and made it really specific for a specific sport or even for a specific team. Save it, send it off, and then you guys can do that inserting of a predicted column yourselves. That's pretty deep. Technically, what I've shown you there, statisticians would be doing that in very complicated tools, writing code. Under the covers here, I have actually been, it has been constructing code, but I can make my statisticians happy by allowing them to register their own data functions. So I've created data functions in R by using all these pull-down menus and pointing it at the right columns and getting it to do stuff for me. But if I want to get a much better, highly accurate, specific for your sport from your data scientists, you can create data functions in R or in S+, or MATLAB or SAS or whatever it is that you like, and feed the data to them and pull the data back out of them. All right, So those are the predictive models that we've produced. Now you are ready to save visualizations that show athletes that are at risk of breaking, or athletes that are at risk of developing an injury or missing a competition, or there's something happening. We can now subtly in Smartabase feed that information to the end users using these visualizations by making things go amber or red on a board like I showed you for the AIS before, to draw attention to those guys. Now the system, I was having a discussion earlier here in the room, the system doesn't have to give hard directives to coaches saying, you guys don't know what you're thinking, but I don't know what you guys are thinking, but the system says you need to pull this guy and change his training regime. You don't have to go down that route. It can be very, very subtle, just to highlight an athlete and to kind of bring them up to the top of the list to say, just watch this person. That's often enough to add value. And of course, once you've done the prediction, you can begin to anticipate it out there and take action, because having the insight after the fact is no good. Having the insight before problems are happening and knowing that things are going to happen, if you can't take action, limited value. So that's why it's critical to get the right information to the right person at the right time for them to be able to do something about it. And sometimes that means socializing it, putting it up on a Facebook-like interface to show them a visualization that they can click through and they'll end up in Smartabase. Sometimes that's what it takes. Sometimes it means getting it out on a mobile device with an app that they happen to be using already. That's pretty much what I had prepared for you today. I'm not quite sure how much time I've got here, probably 10 minutes, but I'm very happy to take some questions, because hopefully I've made you think. Hopefully I've made you think, here's something that we could use in our sport, or to solve a particular business problem that we have, or answer questions that my coaches currently want answered, but they just can't really answer that question for themselves. Before we break into those questions, I wanted to explain why I'm wearing this shirt. You're probably wondering. It's again, you probably didn't notice the stitching, the beautiful stitching in my pants or my shoes, because the shirt is taking all this attention, right? And that just goes to show that visualizations are important. It really draws attention, as you've probably noticed. So let's open it up for questions. Go ahead.
This is probably more personal indulgence. For many years I've tried to find a way to reproduce Hans Rosling's time series bubble graphs. They reckon they did it on Google and it never ever worked. Can we do any sort of animation, presentation of data in your system?
Great question. So I think the animation you're talking about is where you see over time how things change. So you could perhaps visualize a team and say, what are their fitness levels, and represent them as bubbles on a graph, and make them move around so that as the TSBs increase and the sleep increases or decreases, the bubbles move around and get bigger and smaller. It's a great visualization, and yes, I have built those. There are mechanisms by which you can build those things. Caveat on it though, they're really catchy, but sometimes they have only one-time value. So, wow, that visualization is really informative. Now I know what's happened over the past 2 years, but it's not an insightful decision I'm going to make out of it right there and then. Yes. So yes, I can show you how some of those things work. Other questions? Please.
How big would your data set need to be?
So the question is, how big does the data set need to be to get value out of the data? Not big. I know a data analyst who will work with 5 rows. 5 rows in a data set, and he'll find something interesting in just 5 rows. So no, it doesn't need to be big at all. But if it is big, this technology can cope with it very happily. I worked with a very large telecommunications provider, probably the largest in Australia, and I took an hour's worth of calls that were routed through a call system, and we're talking about, I think it was 20 gigabytes of data. And those calls were people going through IVRs. Anybody here been frustrated with interactive voice response? Press 1 for sales and lots of other options, and then 9 for help. So I just looked at the data that was produced in these systems, got back, I think it was something like, 200 million rows of data. It was big data. And I pulled that all into memory, and analysed it, and then was able to draw the call structures of the IVR menus that they had perused, that individuals had perused, or roll it up so that I could take 10,000 calls and say they went into the big menu at the top, and then most people pressed 2 because it's a big bubble, and very few people pressed 1, and a few people pressed 4 and 5, and where exactly they went. So you can work with big data, with small data, and get pretty much you need to evaluate all this data and start looking at it. It's called big data, and it's there for us to use and abuse or ignore. Todd? Yeah.
So this is probably more for the group, but with the predictive stuff, working with you guys, put about 4 objectives, and we actually probably 80% of the work we try to do is just get better basic visualizations of data which we get from Smartabase. So well, that was awesome sort of predictive stuff, and that's sort of where we're trying to get to with probably a lot more work involved, but some of the immediate impact was just to get your daily well-being and wellness sort of on a nice clear sort of on a dashboard, some sort of training loads, another objective, should be able to train time and trying to sort of make that just to make the
Yeah.
So just remember, so I suppose it's not all the predictive stuff, we're just trying to get a lot of the basics down to visualizations.
Agreed. So my objective today is to show you the depth of this technology, because there's so much value to already have at the surface of the technology, but if you are concerned that the depth isn't there, do not be concerned. The depth is right there. You can use it pretty much to the nth degree. But yeah, agreed. A lot of the basic information is right there ready for you to serve up to those that need it. Do we have a question here?
Could you provide some specific tools for mobile access, mobile application, or more touch screen tools than what you have on this?
Yes. So the question is, what can we do on mobile devices? There's 2 sides to it. One is, can we present these visualizations on a mobile device? And the answer is yes. You can put them on an iPad and interact with it just with your finger by highlighting a race that you're interested in and seeing the details of interacting with it, like I was doing on the platform there. And that's how this product is going to be integrated. We're working on that integration. I've seen it. That's how it will be presented through Fusion Sport. The second part is getting really consolidated information, like for example for an individual athlete, how are they doing with their KPIs? There is a mobile metrics component that can take this data and get indicators and predictions and stuff like that, and just feed really narrow information to an individual on a mobile device, just to give them an indicator that they can look at every morning or every couple of hours to see how they're doing. Does that answer your question? A couple more? Absolutely. Domain expertise is the most important thing, because you can just look at the data and draw really poor conclusions by just looking at the data without actually knowing the individuals or the teams or what's actually happening under the covers. How do you get to that domain expertise is the key question, because sitting in a lab as an analyst looking at data, you probably don't know those individuals that you're working with, whereas the coach does. So a visualization technology will allow the coach to look at the visualizations that you've made and even the models that you've constructed to help predict injuries, and they can do things like filter out Joe because Joe isn't performing well because he had a death in the family, and you just don't even want him to appear on the graphs, and you don't want the model to be interfered with because you know that's just an unusual circumstance. And then you know, you can, as a coach, I can apply all the domain expertise that I've got and then reapply the model to do my predictions. Very powerful to be able to put that in the hands of these people who frankly don't even need to know that they're using statistics.
What excites me about our journey is that we've kind of got a lot of experience now on the last side of it, and context of working with coaches and understanding the that context. And that's really where our team's focus is now. By bringing this in, we're going to actually bring all of that data. Again, like I was speaking to clients who just taking all the data straight to an analyst whose core job is analysing traffic or telephone calls or things like that. And without that domain knowledge, they don't actually know what questions to ask. It comes back to those questions. So having that knowledge of the domain of the data is a huge part of it.
Okay, well, I've got to put in a little plug. This is my company, Tibco. I work for them. It's an American software company. They have the product Spotfire, amongst other products that I'm familiar with and that I go around and show to people. The reason that we're very excited is that Fusion Sport has taken Spotfire and is producing these visualizations for you guys on any data that comes out of Smartabase. Okay? If you decide that you want to put some data from your financial systems or around fans and sending them offers and analyzing the fan base, you know, any other kind of data, you can't really use, I mean you could, but you're not supposed to use the Fusion Spotfire environment for that. For that, you'd need to speak with markets who will put you in contact with us, and then we'll talk to you about taking this technology and giving it a broader application. So what I'm going to do is I'm going to leave my business cards here, and very happy for people to tap me on the shoulder. You might recognize me by the stitching on my shoes. But very happy to chat with you. I'll be here for today, but I will be in Brisbane tomorrow.
Sticking around for dinner? Yes. Awesome. Okay.
All right.
Thank you so much. That was
All right. Wow.